There's an interesting fact about angles, and that is that opposite angles are equal. And that can save you a lot of time when answering certain questions. What are opposite angles? If we have any intersection of straight lines, we have opposite angles. There's a straight line, there's another straight line. So the two angles that I'll draw in red would be opposite angles. Rather than just learn another rule about angles, let's quickly see why they are equal. Let's take this angle as being 50 degrees. It could be anything. We're going to prove that the two angles in red are both 50 and will always be the same. Well, if we look at the blue angle to the right, what would that be? Well, it forms a semicircle. That blue angle and the 50 degrees form a semicircle on a straight line. We know already that the angles in a straight line add up to 180 degrees. What is the blue angle then? The blue angle would have to be 130 degrees. That's because 130 degrees plus 50 degrees adds up to 180 degrees, which is the angle on a straight line. Okay, fair enough. We know the blue angle is 130 degrees. How does that help us? Let's focus now on this other red angle. If you see, it's on another straight line, this one going from top right to bottom left. There's another semicircle here. So far we've agreed that the blue angle is 130 because 130 plus 50 on this top left to bottom right straight line has to add up to 180. Well, now let's look at the top right to bottom left straight line. That blue angle of 130 plus the red angle has to add up to 180. So the missing angle with 130 must be 50 degrees. So it adds up to 180. In other words, the angle opposite to 50 degrees is 50 degrees. The angle opposite to 130, if you were wondering, can you guess? It would have to be 130 because it's opposite and opposite angles are equal. We've just proven it. As a final proof, 130 plus 130 is 260, plus 50 plus 50 is 360, and that's the angle all the way around a circle. Let's use that knowledge in action. Here's a typical question you might get. Here's two straight lines intersecting. Actually, let's do more than two, just to confuse the issue. There we go. And we have two angles. Let's do it in light blue. 35 degrees, for example. And we also have the angle here, which is 46 degrees. Your challenge is to tell me what the angles in brown are. And that's the angle X down here and the angle Y in here. Finally, to show off, we could do the angle Z in here. That's only if you're feeling really like having some angle fun. Let's do X first. Do you notice X is opposite the 46? So what must X be? X must equal 46. So this angle is indeed 46 degrees. What do we notice about the Y angle? The Y angle is opposite 35. So indeed, that Y angle must be 35 degrees. So far, just with opposite angles, we've solved two of the three problems. Let's find Z though. It's not opposite to anything, so we're going to need something extra. How would we find this angle here? Well, if we know X is 46, that forms a semicircle on the straight line. So the remaining angle inside the triangle would have to be 180, take away 46, because the angles on a straight line add up to 180. So we just do 180, take away 46 to see what's left over. That would be 134 degrees. That means this angle inside here is 134 degrees. There it is. Now, we have 134 degrees here, 35 degrees there, and we're looking for Z. What do the angles inside of a triangle add up to? The angles inside of a triangle, as I've shown in a different video, add up to 180. What we have so far is 134 plus 35, which is 169. So all that's left over from 169 to get to 180 is 11 degrees. So Z is 11. And we couldn't have done any of that without knowing that opposite angles are equal.